I want you to close your eyes and take a deep breath. Breathe in and breathe out. Wasn't that easy? Well, it's not easy for everyone. I am Tanishq Agarwal, a grade 12 student at Delhi Public School, R.K. I have suffered from asthma and I know what it's like to not be able to breathe. I want to solve this problem.
There are hundreds of millions of people affected by respiratory diseases, including 1 in every 7 children, who then go on to develop chronic respiratory illnesses later in life. This cycle needs to break. The Global Impact of Respiratory Diseases report by the World Health Organization and the Forum of International Respiratory Societies notes that early detection and diagnosis is the most important tool in fighting this battle. The report highlights the need for greater access to spirometers to effectively measure and diagnose pulmonary illnesses. Currently available spirometers fall short of fulfilling this goal. You may have seen cheap spirometers like the ones shown here. Being mechanical tools, each device is calibrated differently, and the readings from device to device can differ immensely. Not only that, taking down correct readings is also a huge challenge. Additionally, these devices measure lung health only in terms of lung capacity and peak flow rate. The standard does not take into account the naturally smaller lungs in the case of children. Even for the case of peak flow rates, a smoker and a non-smoker could have the same PEF values. Yet, this will not indicate sufficiently how healthy their lungs are. So these devices do not give an accurate picture of lung health. The pressure with which you breathe in and breathe out is a more reliable measure of lung ability. The pressure is a direct indicator of the strength of the muscles in your lungs. This measure can effectively differentiate between healthy and affected lungs, be it for children or adults. Devices that measure lung health as a function of their pressure do exist. However, these are extremely expensive and are out of reach of 95% of the world's population. Therefore, there is a need for a new generation of spirometers that are cost-effective, can be mass-produced, and at the same time can measure lung pressure and record the data reliably. To seek guidance in creating such a device, I approached Mr. Deepak Arora, the founder of Biomed Healthcare India. Biomed is a leader in manufacturing medical-grade equipment, including nebulizers, oxygen masks, as well as cost-effective spirometers. After multiple experiments and iterations, we built a digital spirometer that uses a standard Panasonic pressure sensor, a blowpipe that's user-friendly, and a power supply that feeds the spirometer. This pressure sensor, which is capable of digitally measuring air pressure, is already widely used in the packaging industry and is thus readily available. Let's see the spirometer in action. To record your expiratory pressure, simply breathe into the pipe as hard as you can. The value that you get after stabilization is your maximum expiratory pressure. To record your inspiratory pressure, breathe in from the pipe as hard as you can. The value that you obtain after stabilization is your maximum inspiratory pressure.
With this, we are now at the point where we know that this can work for millions of people if mass-produced. The next step in the journey is to make this device more compact and have it sync up with a smart device so that readings can be taken digitally. This can then be integrated with India's Anganwadi framework so that thousands of healthcare workers at the village level can take this data easily, which can then be used for diagnosis by doctors or for further studies and research. In order to make progress in pulmonary care, the affordability and accessibility to medical devices, as well as the reliability of their readings, are important factors that need to be considered. Only by making more devices like this can progress be made in the field of medical diagnostics.